Okay, let's have a look at this question. Car starts from rest at P, moves with a constant acceleration k. 3 seconds later, another car passes through P, traveling in the same direction with constant speed u, and u is more than 3k. Draw a velocity time graph for the two cars, that should say. Let's fix that. Using the same axis and the same scale. Okay, so part 1 here. There we go. Velocity. Let me draw this properly. Whoa. Okay. Time in seconds. And then velocity in meters per second. Okay, so the first car starts from rest and moves with a constant acceleration of k. So starts from rest and moves with a constant acceleration of k. So the slope there is equal to k. Then 3 seconds later, another car traveling in the same direction with constant speed u. Okay, so now actually we could think about this if it should be above or below the line. U is bigger than 3k. So if we just think for a moment, v equals u plus at, the u is 0, the a is k, and the t is 3, and u is bigger than 3k, so I think they'd be wanting us to put it up higher. It goes across like that. Sorry, it should be straight there. And this here is u. So is k. That's all the info on it. Yeah. Hence or otherwise show that the second car will just catch up to the first car if u is 6k, and that it will not catch up otherwise. Okay, so at some point here in the future t, the two cars will have traveled the same distance, we suspect, if they've caught up to each other. So the distance traveled by the second car has to equal the distance traveled by the first car. So the distance traveled by the second car, that one there, that would be t, this is part 2, t minus 3 times u. That should equal the distance traveled by the second car, which is a half the base by the height. And the height here is v, and v is equal to u plus at, and u is 0, and a is k, and t is t, so that's a half t squared k. That's t minus 3 times u. So let's see, we'll solve for t. It's going to be quadratic. Okay, we'll multiply it by 2 and we'll multiply in the u, so that'd be 2 ut minus 6u equals t squared k. So kt squared minus 2ut plus 6u equals 0. So quadratic formula? Well, actually, yeah, it's a quadratic. We want this to be solvable, so, and because we want it to just catch up with it, we want there to be only one solution. So just catch up implies only one time, so the discriminant should equal 0. So that means that b squared minus 4ac should equal 0. U is not 0, so I can divide by 4u actually. So that just leaves me with u. 6k equals 0, so therefore u equals 6k as required. 3. If u is greater than 6k, find the greatest distance the car would be ahead of the first car. So how would be best to do this? Maybe looking at the distance the second car, find the greatest distance that car would be ahead of the first car. Oh yeah, so if the u is greater than 6k, the second car will catch up with it, overtake it, but because the first car is accelerating, ultimately it'll fall behind again. So we want the furthest ahead the second car will be. Now you can take this as a calculus approach or non-calculus approach, but they both actually amount to saying the same thing, that point in time where there's the greatest distance between them happens when the velocities are equal. So like if I just draw a picture here, there's the first car and it's moving along and it's getting faster and faster. The second car moving at a fast constant speed will zip past it. However, because it's accelerating, it will catch back up with it and overtake it. So its gain or its lead will only be momentarily fleeting. It won't stay ahead forever because the first car is accelerating, so it'll eventually overtake it. But at the moment when the two cars are furthest apart, they must be traveling with the same speed, because if this car here was traveling slower than this one here, then the gap would still be increasing. If this one here was traveling faster than this one here, then the gap will be closing. So it's at the moment when they're equal that the gap is kind of the stationary value, the extreme value. So we could say that the velocity here equals the velocity here. This velocity is just going to be u, which is 0 actually. So that's 0 plus kt has to equal, and this one's going at a constant u. So the t will equal u over k. So the distance between them, we can just do calculate the distance of each. So the distance travelled by the second car would be t minus 3 times u, and that should then take away the distance travelled by the first car, which we can see is a half the base by the height, which is e, which is u plus at, which is kt, so that's a half k t squared. And we actually know the value of t, so that would be u over k minus 3 times u minus k over 2 u over k squared. That's the distance. So let me see, there's a 2 down below here, so it'd be nice to put a 2 here and a 2 here. Then what I can do is have a common denominator. Actually that's well, actually when that expands, that would be u squared and k squared, and that k will cancel with that, so it's going to be all over 2k, that's for sure. That's going to be a minus u squared, and then that's going to be 2u squared minus 6u. No, I have to be careful because this one's not over k, so I should put that a k there and k there. Now they're all over k. So this is all over 2k as well. So that's 2u squared minus 3uk minus u squared. So that would be u squared minus 3uk all over 2k. I guess I could take the u out. u minus 3k over 2k. So again, you can see why the u has to be bigger than 3k, so this distance is a positive. Okay. Was there any other way to do it? We're finished the question, but I will show you the calculus way. So this is car 1 and this is car 2. So the distance between the two cars, that would be S2 minus S1, which is equal to t minus 3 times u, the usual story here, minus a half kt squared. That's the distance between them. To make this a maximum, we need the derivative. Actually, let me clean it up a little bit first. ut minus 3u minus a half kt squared. So to get the maximum, we need the derivative. That's u, that's gone, and that's kt, and that should equal 0. So that means t should equal u over k, which is the exact same result I got using the non-calculus method. Then I just sub that back into there. So d would equal ut minus 3u minus a half k t squared, which is u squared over k squared. K's cancel. That's u squared over 2k minus 3uk minus, that's over 2k, u squared, that's equal to u squared minus 3uk over 2k, so that's the same thing. So for those of you who prefer calculus, that's the calculus approach there. Okay, I believe everything's in order here.